Introduction. Framo pumps are designed for long-term, safe and profitable operation. This is of great importance to use appropriately, in accordance with the instruction of pumps, in order to ensure the long-term use. In addition, carrying out of special maintenance, and keeping clean of the hydraulic system, should be required. Pumps should be used in the direction of their capacities, and dry use should be avoided. It should only be used by knowledgeable and experienced personnel, for safe and economical operation. The aim of training. As known, on many tankers, Framo pumps are used. While these pumps are quite operable, and problem-free to operate, them in accordance with procedures, will ensure both long life, and economic. Because establishments give great importance for energy conservation, to respect procedures in this training, and Framo pumps manual strictly has a great importance. The purpose of the training is to create awareness for officers to use Framo pumps efficiently. Content. Chapter 1, General Operation. Chapter 2, Feed Pump and Power Pack. Chapter 3, Discharge and Stripping Operation. Chapter 4, Purge Operation. Chapter 5, Portable Cargo Pump and Crane. Chapter 6, Water Test and Sample System. Chapter 1. General, Hydraulic and Design, Operation. You can see the industrial design figure of Framo pumps for analyzing parts. The pumping system consists of hydraulic motor cargo pumps, ballast pumps, tank washing pump, portable pump and power consumption units, each of which is connected to the hydraulic power unit by a hydraulic circuit. Cargo pumps are centrifuge pumps with one step, which have very well pumping and stripping performance of any sort of fluid. Its impeller is close to bottom of tank. It is placed in a cofferdam, separating the hydraulic oil from the cargo completely. The hydraulic power supply consists of hydraulic power packs which are performed by electric motors and diesels. Pump displacement is hydraulically controlled via the pressure regulator on each pump. With this system, the oil delivered from the hydraulic pumps remains the same as the oil consumption in the hydraulic motors. A control valve is installed in each motor to control the speed of the motor and to adjust the limit level. A flow filter and cooler are installed on the main return line to keep the hydraulic oil clean and keep the oil temperature at the desired level. To prevent backflow in the hydraulic system, the system should be kept with pressurized even when it is not in use. This pressure is achieved by a jockey or feed pump. Due to the centrifugal force created, the rotation of the impeller ensures that all the liquid in it to flow upward. The liquid leaving the impeller's eye or center flows to fill the space in the suction line. General view of the Framo pumps. Low pressure hydraulic pipe. It is the return line for the cargo pump. The oil used to start the engine is returned through this pipeline. The pump unit is connected to the deck with this pipe. Cargo pipes. While the motor and impeller are running, the cargo is forced to move on this pipe. Cargo pumps. For vessel with this type of pump, the cargo handling systems are designed to load, discharge 6 different cargoes simultaneously and without the pump room. Loading can be performed simultaneously via the main cargo system, cargo pump and loading pipeline. There are one hydraulic cargo pump for each tank on board. Sample pump features of a 50,000 deadweight vessel. Chapter 2. Feed Pump and Power Pack. Feed pumps. Feed pumps can be operated manually from the control panel or electrical cabinets. While the first power pack is running, 2 feed pumps shall automatically run in high capacity mode before the power pack is started. When the power packs are stopped, the feed pump shall automatically switch from the high capacity to low capacity mode within 10 minutes, and only 1 feed pump shall be in operation. Synchronously, only 2 feed pumps may be operating at the same time, and the system does not allow the third to operate at the same time. There is an indication that shows the pumps are running in the control panel. The high capacity mode is used to keep the suction end of the main hydraulic pump pressurized. So it should be ensured that each of the 2 feed pumps were running before the power packs were on. While the power packs are in operation, if one of the feed pumps operating in high mode stops, the third feed pump will automatically switch on. If the third feed pump operation signal cannot be received within 3 seconds, the system shall give the feed pressure alarm and shall collapse. Even if the system is not running, one of the feed pumps should be left running. If it stops, the system shall give low pressure alarm. If the system collapses, the feed pumps shall stop with the first power pack shut down. Feed pump indicator. Power packs. Power packs can be operated manually from the control panel or electrical cabinets. Power packs can be started in any order. The power packs, which are the main hydraulic power units of the Framo system, can be electric motor driven or diesel motor driven. The operation of the power packs, only the use of the power pack as needed, stopping of the power packs in case that the discharge stops. It should be displayed sensitivity for preventing energy conservation by operation generators at minimum number, maximum loading in compliance with requirements power pack. While the various pumps in the system are making consumption in due course of operation, the power pack units distribute the necessary hydraulic oil is required for a pump operation, and the power pack is responsible for providing the required oil. In order to minimize economic discharge and equipment wears, it is necessary to pay attention to the relationship between the number of power packs used and the number of hydraulic motors used. Sample hydraulic oil consumption for a 50,000 deadweight tons vessel. Hydraulic oil supply. 2 hydraulic electric power pack. 2 by 806 liters per minute equals 1612 liters per minute, 276 bar. 2 diesel hydraulic power pack. 2 by 805 liters per minute equals 1610 liters per minute, 276 bar. Total of hydraulic oil supply equals 3,222 liters per minute, 276 bar. Simultaneous operations. 6 cargo pumps SD200. 600 cubic meters, H-125 mLC-0.75 kilograms per cubic decimeter -1.0 CST, equals 3,204 liters per minute, 250 bar. Oil consumption. You can examine the consumption by power pack type and quantity. Oil temperature. Controls before operating the power pack. Make sure that the service valves on the hydraulic pipeline are open. These valves should only be closed when maintenance is performed. Check the level of the hydraulic tank and make sure it is within the required level. Check hydraulic oil temperature. Recommended operation temperature is between 30 degrees Celsius minus 55 degrees Celsius. If the oil temperature is below 20 degrees Celsius, Run one power pack and circulate oil until the temperature reaches the required level of a heating and ventilation valve which was installed on system. 100 bars circulation pressure should never be exceeded during heating. Make sure that the coolant pump and the ventilation fan in the hydraulic room is running. Check that the pump controls and the potentiometer on the system are adjusted to the minimum position. Make sure that sufficient number of generators are running. Make sure the cargo pump cofferdams are purged. Switching of the power pack. Reduce the hydraulic system pressure to minimum. Stop the main power packs. Stop the coolant pump and fan. Stop the unnecessary generators. Stop the feed pump and restart it at low level. This shall be done automatically within 10 minutes if this process is not done manually. To prevent overpressure in the hydraulic system, it is always necessary to leave a feed pump or jockey pump running at low speed. While power packs are off, if the cargo fugitive happens accidentally in the hydraulic system, the oil and cargo mixture shall pass to the system. To prevent this, the hydraulic system pressure shall always be greater than the cargo static pressure. When the hydraulic system is not in use, a feed or jockey pump shall provide a pressure of about 4 bar. A feed or jockey pump should always operate at low speed and all valves in the main return pipeline and in front of the cargo pump should be kept open. Chapter 3. Discharge and stripping operation. Discharge operation. If you want the pump to run efficiently for a long time, run the pump between its operating values. Start the hydraulic system and check that there is enough power. Local control valve and cargo discharge valve must be closed. Look at the picture for example. After pressing the button, operate the pump for 1 minute, and with a hydraulic pressure of approximately 50 bar. Open the cargo discharge valve. Do not keep this valve closed for a long time. If the cargo valve is closed for a long time, the pump damages. Examine to the required manifold pressure or discharge capacity by increasing the hydraulic pressure. Important note. Check that it is 20 bar lower than the oil pressure in the main system while adjusting the pump pressure. This value is the highest operating pressure that required set by user. The end of discharge. If vibration in pump and pulse in the hydraulic oil pressure start after decreasing cargo pump suction, reduce the pump capacity by reducing the hydraulic engine pressure and prevent the pump from running dry. Meanwhile the cargo tank is empty, the hydraulic motor pressure falls and in this case, the cargo discharge valve is closed and the pump is stopped. The pressure setting is adjusted to the minimum position. If the pump is to be restarted, the vacuum that has been in the cargo pump pipeline should be broken. Look at the stripping process for this process. Pump operation with local control valve. Unscrew the local control valve counterclockwise while the cargo discharge valve is in the closed position. Bring remote control valve to maximum position, remote control closed. Turn the local control valve to the right, switching off, and run the pump. Set the hydraulic oil pressure at 50 bars. Operate the pump at this condition about 1 minute. Open the cargo discharge valve. Increase the oil pressure of the hydraulic motor to reach the desired discharge pressure or pump capacity. Termination of cargo discharge. When the cargo is reduced in the suction part of the pump, pulse, interruptions and pinking occurs in the hydraulic oil system and vibration occurs in the pump body. In this case it is necessary to reduce the pump capacity, not to come to the pump damage caused by dry operation. As soon as the tank is empty, the hydraulic engine pressure shall need to be lowered. When the tank is empty, the hydraulic motor pressure drops. Immediately close the cargo discharge valve and switch off the pump, by opening the hydraulic pressure control local valve. Resetting of the system for remote control. After the local control valve is fully closed, move the position of the remote control valve to the minimum position. If the pump is to be reoperated, the vacuum in the cargo piping line should be broken. See stripping section for this process. Parallel operation of the pumps. The local control valve and the cargo discharge valve should be closed. Run the hydraulic system and adjust the pipeline pressure to approximately between 100 and 150 bars. This pressure value may vary depending on the pipe system condition, the specific gravity and viscosity values of the cargo. See the pump performance diagram in these conditions. Firstly, run the first pump and let it run for 1 minute at about 50 bar. Increase the hydraulic motor pressure to allow the cargo discharge pressure to rise above the cargo manifold pressure. Open the cargo discharge valve. Adjust the pump hydraulic motor pressure to the maximum level. Start the cargo pump. The cargo discharge valve of this pump shall be closed. As stated in Article 3. Check that the pump discharge pressure is higher than the manifold pressure, and, if necessary, allow the cargo discharge pressure to rise above the manifold pressure by adjusting the motor pressure. Open the cargo discharge valve after this is achieved. Start discharge and bring to peak pressure by bringing the hydraulic motor pressure and the control valve handle to its maximum position. Check that the tank level has dropped in the meanwhile. After that, put into use other pumps one by one as described above. According to the parallel pump, to be operated in the system, providing for the required hydraulic pressure and, if necessary, increase the pressure. Increase the hydraulic oil pressure to provide the required discharge pressure and, or capacity. During the parallel operation, the cargo level in the tanks may be different. For this reason, it may lead to pressure loss in the deck pipeline. In such a case, it is necessary to adjust the hydraulic motor pressures separately and the pump capacity is brought back to the initial capacity. Close the pump cargo discharge valves when good levels decrease in the cargo tank and stop the pumps. If the pump is to be reoperated, the vacuum in the cargo pipeline should be broken. See stripping section for this process. Action to be taken while 4 pumps are running. Increase the motor hydraulic pressure when the cargo discharge valve is off. Open cargo discharge valve. Increase hydraulic motor pressure. You can see. Cargo discharge valve is open, 2 pumps. Cargo discharge valve is open, 3 pumps. Cargo discharge valve is open, 4 pumps. 4 pumps are running by increasing of GI hydraulic system pressure. At the figures. It is recommended that a more number of pumps should be operated at a low hydraulic pressure in parallel run instead of less number of pumps running a high hydraulic pressure, for that the system can operate for a long period of time. An operation such this way provides a low hydraulic system pressure, a lower volume level, and less wear on the systems. However, in case that it is necessary to discharge a low specific gravity cargo through a very long coastal circuit, the pump may have to operate at the highest speed to provide the required discharge pressure. It should not be forgotten that the capacity of two pumps operating at 100% speed, and are the same with the capacity of four pumps operating at 50% speed. You can see the graphic about purging medium pressure in cargo pipe by minimum required hydraulic pressure to prevent backflow through impeller. The pipeline on the deck should be considered, and it should be transacted with the experiences gained on board to provide the best conclusion. The best stripping process is done at least in back pressure condition. Being high of back pressure makes the flow of cargo difficult, and increases the time of the stripping process. Likewise, high cargo viscosity negatively affects stripping time. For example, purge pressure minus static head minus back pressure equals available purging. 7 bar minus 2 bar minus 0 bar equals 5 bar. 7 bar minus 2 bar minus 3 bar equals 2 bar. The stripping time varies depending on pump size, back pressure, piping system, cargo suction well, purging average pressure. Preparations to break of vacuum in pump cargo pipe. Purging of cargo deck pipeline. Close the cargo discharge valve when the tank is empty. Connect the air pipe to the draining valve. Open the air valve to be used for purging, and break the vacuum. Close the purge valve. Note: purging air pressure must always be higher than the cargo line pressure. Purge the cargo deck line and the terminal line to the slop tank, or another cargo tank, depending on the procedure on board. Close the manifold valves. Release the pressure in the pipeline on deck to the tank by opening the stripping valve C. Start the pump by using the local control valve, and increase hydraulic pressure to 90 to 120 bar. Note: the optimal hydraulic pressure is depending on the specific gravity of the cargo, viscosity, average purging pressure, exit pressure. The experience gained on board should be valid in this regard. Open the stripping valve. Open the cargo scavenge valve. Start scavenge process. Continue stripping process until the pump cargo pipeline is completely drained. Check the speed change of the pump at short intervals. Note: do not run pump if it is not needed during scavenging. Close the scavenge valve, and then close the cargo scavenge valve. Stop the cargo pump. If necessary, scavenge the cargo deck line and redo the stripping process. Close the valve and separate the purge hose. As an alternative, stripping process to the slop tank with the pump can be done via a specially specified pipeline. Also, it can be stripped, with the low manifold pressure, to the cargo terminal on the deck pipelines. However, the stripping time shall increase, depending on the pressure. Emergency stop buttons. Emergency stop buttons can only be used for emergency cases, and should not certainly be used for routine operations. When it is stopped with the emergency stop buttons, the system is overloaded and should not be preferred except in critical situations. Manifold sight, port side and starboard. In front of accommodation. In cargo control. In engine control. While some stop buttons on your vessel stop some group pumps, some of these may only be designed to stop all pumps. Please check when you are on board. Emergency stop buttons should be used if the following points are in question. In case that there is a leak in the hydraulic pressure pipeline or hoses. In case that it comes to critical pressure jumps in the system. In the case of critical vibration in the power packs. In case that cargo pipelines are damaged. In the case of uncontrollable pollution, effusive, that occurred during discharge. In case that the system is stopped in an emergency. In case that the tank has a very low oil level. Valves closing on return pipeline. Low feed pressure. It may cause damage such as the feed pump malfunction while operating at high speed. The source of the fault should be researched and repaired before the system is restarted. Before the system is restarted. Reset the system. If necessary, add oil to the tank. Ventilate the system completely and restart it according to normal procedures. Chapter 4. Purge operation. Purge process. It is very important to purge the pumps at regular intervals. To purge protects the system against damages, and allows it to be detected, in the event of a leak. It allows you to observe the situation of the seals. Preparation for purge process. Put an appropriate bucket under the exhaust trap ventilation circuit. Check under draining valve and exhaust trap against possible wastes that may remain from previous load. Make sure the draining valve is off. Make sure that the relief valve, on the hydraulic relief valve is open. Connect the air, or nitrogen hose to the purge connection. Make sure that you drain the hose before connecting. Open the valve on the air, or nitrogen supply. Check whether air, or nitrogen comes from the exhaust trap. The relief valve is adjusted to an opening pressure about 3 to 3.5 bar. Therefore, very little air, or gas leakage in this valve is normal. Close the valve on the air, or nitrogen supply to finish purge process. Purge process. Put the bucket under the draining valve, open the valve and wait for it to be draining of leakage in the circuit. Remove the air, or nitrogen connection hose. Close the draining valve. Evaluate the amount of leakage collected in the bucket and prepare a purging report. You can examine the figure for purging process. Purging form. You can see an example of purging routine for Framo submerged cargo pumps table. The pumps should be purged at the specified intervals and with the right procedures in order to monitor the condition of the pump cofferdam. Neglecting to purge can cause serious damage, such as cofferdam obstructions. Each horizontal interval on the form has been prepared for a cargo in a tank, from loading until unloading. If the vessel is loaded more frequently in a tank than in other tanks, an extra form should be arranged for that tank. Prepared purging forms should be sent to Framo and ship owner and kept on board in a copy. The crew is primarily responsible for the purging process and the necessary precautions. Purge intervals. Loading. Just before loading. At sea. 1-2 days after loading. If no leakage observed at the first step with 15 days of interval. If leakage has been observed at the first step or the other steps, purge must be performed daily. If the operator intended to circulate the cargo, cofferdam must be purged before and or after each circulation. Discharging. Just before discharging and just after discharging. Assessment of purge results. You can examine the table for purge results. The cargo, hydraulic oil in the cofferdam may come from the shaft seals in the pump unit, from the flange seals, or from the damaged, cracked circuit, pump unit, cofferdam circuit. Loading leakage which comes from shaft seals and is close by 0.51 per day during pump operation is normal and the seals do not need to be changed. The loading leakage can also vary depending on the load being carried. Loads such as naphtha are more corrosive to seals in proportion to lube oil. If the load leakage increases to around 2 liters per day, the pump should be purged several times in a day, and originating leakages from should be investigated. Pressure test should be done as quickly as possible. The oil leakage of 0.25 liters per day coming from the mechanical oil seals is normal during the pump operation. If the leakage continues to increase and cannot be avoided, the pump should not be used and it should be operated with the emergency portable pump. Chapter 5. Portable Cargo Pump, and Crane. Portable Cargo Pump. You can examine the figure to understand well. The Framo Portable Cargo Pump is a hydraulic single-stage centrifugal pump designed for use when normal pumps fail. The pump head is connected to a hydraulic hose for pressure and return oil. The speed control valve is for adjusting the discharge ratio and turning the pump on, off. The extension hose, pressure and return, is used to connect the pump to the hydraulic pipeline. The speed control valve, and the couplings used to connect the pump to the hydraulic pipeline, are sent to the vessel in a separate box. You can examine the figure to understand well. Purge process. Portable pumps should be kept dry and clean in an easily accessible location. The concentric hose, the cargo hose and the extension hose should be kept in a hose cabinet or by installing them on an appropriate location. Pumps and hoses should always be kept secure and supported against abrasions caused by ship motions. Hoses should never be installed on sharp and abrasive surfaces. It must be protected against torsion and crushing. The box containing the equipment required for installation should be fixed close to the pump. You can examine the figure to understand well. Preparation for portable cargo pump usage. Install quick couplings to the hydraulic circuit, closest to area where the pump shall be used. Low pressure and high pressure quick couplings are in box. Close ball valve. Open the plug on the ball valve to release the pressure. Remove blind flange. Make sure the O-ring seals are in proper place. Install low pressure and high pressure quick couplings. Put nut on a quantity of molybdenum disulfide in the mollicot grease tube in the box and tighten with 45 Nm torque. You can examine the figure to understand well. In case of a leak on the valves in the pressure section, the hydraulic return hose should absolutely be installed before the pressure hose to prevent formation of pressure in the pump return section. Connect firstly the return hose, while connecting the pump. Remove absolutely firstly the pressure hose while removing the pump. Connect the return hose, while connecting return hose. Fix the couplings by tightening the rings on the female couplings. If necessary, open the plug on the quick coupling station to release the pressure. While connecting pressure hose, close the ball valve on the main pressure circuit. The speed control valve should be off. Turn counterclockwise until the compensator valve closes. Connect the pressure hose and the speed control valve. Fix the couplings by tightening the rings on the female couplings. If necessary, open the plug on the quick coupling station to release the pressure. Open the ball valve in the main pressure circuit. Run the pump by slowly turning the valve counterclockwise. Run the pump for 30 seconds on deck by flushing the impeller suction area with fresh water. Stay away from impulses in the rotation. Observe where the hydraulic oil is leaking or other abnormalities that may occur in the impeller operation. Such abnormal sound, etc. Inspect all hoses before inserting them into the cargo tank. Check whether there is mechanical damage. Portable cargo pump usage. Lower the hose into the cargo by using the portable crane. Flexible hoses should not be used for lowering and lifting purposes. Hoses should not pass over sharp areas. Use the hose saddle to protect the hoses. Slowly turn the compensator valve on the control valve clockwise until the desired capacity is achieved. The end of discharge. When the pump begins to lose suction, as is also understood from vibrations and hydraulic pressure pulses, drop the pump's capacity against dry running and abrasions. Empty the tank at low hydraulic motor pressure. While stopping the pump, turn the pump off by turning the compensator valve counterclockwise. Close the ball valve in the pressure holding coupling station. Release the pressure in the extension hose by keeping the compensator valve open for a short time. Cleaning and storage. Before being placed where it is to be stored, the portable pump and flexible hoses should be thoroughly cleaned and ready for reuse. Run the pump for a while the valves are closed in the cleaning water. To clean the pump, discharge the water used to clean the cargo hose. Alternatively, operate the pump in a freshwater-filled drum while the valves are closed, while pump discharge flanges are blind. Use steam or fresh water to clean the outside of the pump and hoses. Definitely do not use seawater. Disconnecting hoses. Open the plug on the quick coupling station to release the pressure and minimize the disruption of quick couplings. Remove first of all the pressure hose, then the return hose. Always close the valve at the pressure circuit and disconnect the pressure hose before the return hose. Remove the high pressure and low pressure couplings on the hydraulic circuit and install the blind flanges. High pressure and low pressure couplings and speed control valve should be placed in the equipment box. Drain approximately 1 cup of hydraulic oil from the extension hose and concentric hose. This process is intended to prevent pressure that can occur in temperature variations. The quick couplings on the hoses should be greased. Check all hoses against mechanical damage. Check the pump cofferdam against leaks. To do this, remove the impeller nuts and lift the pump head in a vertical position. Disconnecting hoses. Any leakage on the cofferdam shall come from impellers. If the cargo gets leakage, change the cargo seals for the next use. A small amount of hydraulic oil leakage is normal. The pump should be kept dry together with the concentric hose and cargo hoses. Portable cargo pump tests. Check all connections to see whether there is oil leak. Drop the speed and stop the pump. Remove the extension hose from the hydraulic pipeline. Remove first of all the pressure hose, then the return hose. Drain approximately 1 cup of hydraulic oil from the extension hose and concentric hose. Check the pump cofferdam, whether there is oil leak in it. Remove the impeller nut and lift the pump head up in a vertical position. Check all units visually. Portable pump cargo hose should be visually inspected once a year and leakage test should be done. Emergency cargo pumps should be tested once a year. 2. No emergency cargo hoses need to be used during the test phase. Emergency cargo hose is subjected to 1-hour test with 3 bar air pressure once a year. 3. Absolutely use fresh water for testing. 4. Install the return pipeline flange to the connection made for the emergency cargo pump on the hydraulic return line. Install the input circuit flange to the connection made for the emergency cargo pump on the hydraulic circuit. Whenever a connection is made, always first connect the return pipeline. Connect the suction pipeline after connecting the return line. Install the hydraulic return hose to the emergency cargo pump hose. Install the speed control unit to the other part after installing the hydraulic return hose to the emergency cargo pump hose. Install the hydraulic suction hose after the speed control has been installed. Put the pump into the barrel so that it is completely in the water and fix it so that no load is placed on the hydraulic hose. Adjust the closed Framo valve on the hydraulic line to the open position. Turn the pump to the right to turn it over. Turn left to decreases the speed of the pump. First run pump at very low speeds. Increase the pressure to 7 bar after starting at 3 seconds low speed. Check the hydraulic leakage. Start to decrease slowly the speed of the pump and stop it. Always remove the input hose first and then the return hose. Drain hoses. Check cofferdams of the pump. Make the coil of hoses as so not gain the range and stow. All equipment should be stowed and stored in the clean and dry storage. Portable pump. Cargo pump is used with portable crane. Please, open the tank cover to be installed and stow the installation area. Please bring portable crane tank next to the control equipment and check equipment. Adjust the feet to the center of the tank cover after pull the wrap chain off. Please reinstall and refix the butterfly valve, after removing the butterfly valve and installing it to the crane to install the air motor. Please install the motor, air connection and check the chain link. Bring the motor to 1 position, for lowering. Bring the motor to R position for heaving up. Portable crane is ready to operate up and down. Chapter 6. Water Test and Sample Ship System. In accordance with MARPL Annex 2. Water Test Procedure in accordance with MARPL Annex 2. Ref. AN Annex 2 Appendix 5 Item 3 3.1 to 3.2. The cargo tank should be checked according to the closed area and make sure that the relevant pipelines should be clean so that you can safely enter the cargo tank. Provide a pressure of 100 kilopascals, 1.0 atmosphere, from the cargo tank in the manifold. The vessel trim's max should be 5 degree at aft and slope should be 1 degree max. While this test is carried out, fill the cargo tank with water. The water level should be the amount that shall remain in the tank at the end of a normal cargo discharge operation. The test can be done with seawater, but at the end of the test, the tanks should be washed with fresh water and cleared the salinity. As written in the stripping process procedure, Article 1 to 6, release the pressure in the cargo line and make the purge process. Write the time when the cargo purge valve, Ref Step 9, is opened, while performing the normal stripping procedure. Also write the time while the stripping valve is closed, Ref Step 11. Times taken should be recorded. Residues are collected, measured, and recorded. Note: the cargo deck line should be measured separately. The waters to be collected are taken to a calibrated barrel, or tank. Water from the cargo tank suction section, and its around. From anywhere in the cargo trapped in the tank. From the pipe in the relevant tank of the cargo pump to the manifold. It should be collected from the lowest drain section of the cargo pump. 50 tolerances per tank are acceptable limit. Sample ship system schemes. Please click next to see other samples. Congratulations! You have completed the training. Now please complete the evaluation exam.